Welcome to the session on Windows networking troubleshooting. What causes networking problems? In this session, we step back from the technical architecture of the previous session and ask a more practical question. Why do networks fail in the first place? The answers range from faulty drivers and misconfigured settings to building construction and, most commonly of all, the people who use the network every day. We'll cover the full spectrum: Wi-Fi driver issues, hardware failures, user error, software conflicts, update management, and how to use Device Manager as a diagnostic tool. By the end of this session, you'll have a framework for diagnosing any network problem before you touch a single command. There's a common misconception that a computer is an isolated machine, something you sit down at, use for a while, and then leave. In reality, no computer is isolated. Everything is connected to everything else all the time. Think about a typical household. At any given moment, you might have tablets, laptops, desktop PCs, gaming consoles, smartphones, smart speakers like Amazon Echo, IP cameras, NAS appliances, smart televisions, and even a smartwatch, all on the same network, all connected through the same router, all ultimately linked to the global internet. Extend that to the average workplace, and you add network switches, servers, printers, scanners, additional IP cameras, and visitor devices on the guest Wi-Fi. All of these connect through cloud data centers to services like Office 365, email systems, Dropbox, Amazon S3, and remote intranet sites spanning the globe. These connections travel through fiber optic cables, cellular masts, telephone exchanges, and ISP data centers, some of which are regulated by governments. The result is staggering. Every device on Earth is, theoretically, connected simultaneously to every other device on Earth. This interconnectedness is what enables criminal botnets, requires firewalls and antivirus software, and also makes sharing a photo as easy as a single tap. Here's something that might surprise you. The biggest threat to your PCs and networks isn't hackers, criminals, or even poorly written code. By far the biggest threat is the people who need to use them. There's an old saying in IT that goes, "A PC left in the box and never plugged in will never go wrong." It's a bit of a joke, but it's also very accurate. The more a computer is used, the more chances there are for something to go wrong, and the people using it are almost always at the center of that. Now, you might say that's unfair. Shouldn't the software vendors, hardware manufacturers, and operating system developers bear responsibility? Yes, absolutely. And this brings us to Microsoft Windows, which faces three genuinely difficult challenges. First, Windows must remain backward compatible with software and hardware that predates the World Wide Web, sometimes by decades. Second, it must be compatible with tens of thousands of new hardware devices and software applications released every year, often on day one of their release. Third, Windows consists of hundreds of millions of lines of code, and not a single person on Earth can keep complete track of all of it. Given those constraints, it's frankly remarkable that Windows works as well as it does. The engineers who build it are, by their own admission, ordinary fallible humans, which means bugs, incompatibilities, and unexpected failures will always be part of the picture. You may have heard the old song, "Dem Bones," about how every bone in the body is connected to the next. Computer networking works the same way. When a PC loses its network connection, the problem might not be in the PC at all. It could be the cable between the PC and the wall socket. It could be the wall socket itself. It could be the switch, the router, the ISP's street cabinet, the ISP's network backbone, or even a construction crew that just cut through a fiber cable on the street outside. This is why thinking holistically is essential to diagnosing network problems. The first question to ask is this problem isolated to one device, or are other devices also affected? If multiple devices are experiencing the same issue, troubleshooting that single PC will get you nowhere. The problem is upstream. The second question is, has something changed recently? On the PC, on the network, or in an environment? Most networking problems have a change at their root: a driver update, a new application, a configuration edit, or a hardware swap. The third question is, has this happened before? If a problem is recurring, it likely has a persistent underlying cause: a fragile driver, overheating hardware, or a recurring update conflict that needs a permanent solution rather than a temporary fix. These three tenets, isolation, change, and recurrence, will narrow your diagnosis faster than any command line tool. Wi-Fi is now the dominant form of network connectivity. The latest Wi-Fi standard, 802.11ax, supports speeds up to 10 gigabits per second wirelessly, and researchers at the University of Surrey have already demonstrated 1 terabit per second speeds over 5G. Ethernet is fast being superseded for general use. But with this shift to wireless comes the number one cause of network connectivity problems: Wi-Fi driver issues. There are 6 main causes. The first and most common is driver updates. Whether delivered automatically through Windows Update, a vendor's driver update app, or manually by a user, a driver update is far more likely than anything else to break a working Wi-Fi connection. The second cause is fresh OS installs. A clean Windows installation on a laptop or tablet that isn't connected to Ethernet may not find the correct Wi-Fi driver, and without Wi-Fi, it can't go online to download the right one. In this situation, you'll need a USB flash drive with the driver on it or a USB to Ethernet dongle to get online. Third is broken or disconnected antennas, which are less common but can cause complete signal loss, especially on laptops that have been dropped or disassembled. Fourth is software and hardware conflicts, particularly vendor-supplied Wi-Fi management utilities that can develop faults or conflict with Windows. Fifth is signal issues. Dead spots caused by building materials, distance, or interference are more common than people expect. Sometimes simply walking to the next room confirms the diagnosis. And sixth, connecting to the wrong network. This happens with surprising regularity and is always worth checking first. The single most valuable tool for diagnosing any of these problems? A USB to Ethernet dongle. With wired connectivity, you can download the correct driver, reset network settings, and rule out the wireless hardware entirely. Another very common cause of connection problems is a misconfigured or corrupted network settings profile. When a PC can no longer connect to a specific Wi-Fi network despite the network being available and functioning normally, the connection profile stored on the device may have become corrupt. The solution is to delete the saved profile for that network and reconnect from scratch. This requires knowing the Wi-Fi password. The process differs depending on the Windows version. In Windows 7, open the Network and Sharing Center from the control panel. Click Manage Wireless Networks in the left pane. Then right-click the network you want to remove and select Remove Network. In Windows 8.1, open the Settings app, go to the Network panel, find the Wi-Fi section, click Manage Known Connections, select the network, and click Forget. In Windows 10, go to Settings, then Network and Internet, find the Wi-Fi section, click Manage Known Networks, select the network, and click Forget. For all versions of Windows, you can also delete network profiles from an elevated command prompt. The command netch WLAN show profiles lists all saved Wi-Fi networks. Then netch WLAN delete profile name equals, followed by the network name in quotes, removes it. And here's a useful bonus tip. If you need to find the password for a saved network, run netch WLAN show profiles name equals the network name. Then key equals clear. The password will appear in the key content field. Let's look at 2 more major categories of networking problems: physical hardware issues and user error. On the hardware side, the most common issue is snag cables. When users trip over or accidentally pull Ethernet cables, the results range from a simple disconnection to serious damage, including broken network ports on motherboards, which can require expensive replacements. Keeping cables tidy, properly routed, and away from walkways is an essential preventive measure. The placement of network hardware also matters. Equipment in excessively hot, cold, or dusty environments will degrade over time. Good ventilation and clean conditions extend the lifespan of every piece of network hardware. Mobile devices present their own challenges. Dropped, thrown, or poorly handled devices can suffer damage to internal Wi-Fi antennas and connectors, often without any visible external damage. Now for user error, which is, and we say this with great sympathy, almost always present in some form. Users regularly change network settings without understanding the consequences. Unless settings are locked down via group policy, there is essentially no limit to what a user can accidentally reconfigure on their own machine. One very common example: a user connects to a different Wi-Fi network to get a stronger signal, only to find they've lost access to the local network storage. Their internet works beautifully. Everything else is stopped. BYOD, bring your own device. Situations make this worse because on a personal device, the user is their own administrator. You often lack the permissions to lock down the settings you need to protect. The most powerful diagnostic question in these situations is simply, what changed? Ask it, press for an honest answer, and you'll save enormous amounts of diagnostic time. Updates and patches fall into two categories: those from Microsoft via Windows Update and those from third-party hardware vendors. Microsoft updates can be managed and controlled in enterprise environments using Windows Software Update Services, or WSUS. With WSUS, IT teams can test updates against their specific hardware and software combinations before deploying them to the entire organization. This is critical. A single incompatible driver pushed to a fleet of identical SMB machines could render all of them unusable simultaneously. Outside of enterprise environments, control over updates is more limited. Windows 10 has made security, stability, and driver updates mandatory. You cannot fully opt out. However, Windows 10 Pro and Enterprise users have two useful options. Current branch for business delays feature updates for up to 3 months, and a long-term servicing branch, available on Enterprise editions, delays feature updates for up to 10 years. Neither option delays security or driver updates. Third-party vendor utilities present a different challenge. Drivers for Wi-Fi hardware frequently bundle proprietary connection management utilities that launch automatically at startup and take control of the Wi-Fi connection process. In enterprise environments with specialist security settings, these utilities can completely break connectivity. Disabling the utility is sometimes not enough. If the vendor installed a background updater, the utility may re-enable itself weeks or months later. Vigilance is required. Remember, while if it ain't broke, don't fix it is a good general rule, it doesn't apply to security patches. A stable driver that hasn't been updated in 2 years may contain serious security vulnerabilities even if it connects to networks perfectly. For Windows Pro and Enterprise, the group policy setting, turn off Windows Update Device Driver Search Prompt, found under Administrative Templates, System, Driver Installation, prevents users from being prompted to install driver updates on their own, reducing the risk of problematic driver installs without eliminating security patches. Once a driver is installed, Device Manager, available through the control panel or by searching, is your primary tool for diagnosing and managing it. Device Manager's Driver Properties dialog has 4 tabs you should know. The General tab gives you the most important at-a-glance information: whether the device is working correctly, the driver version number, useful for verifying you have the right version or confirming a recent update changed something, and the option to enable or disable the device. The Advanced tab provides adapter-specific configuration options. Depending on the exact network adapter model, you may find dozens of configurable parameters, some of which are needed to connect to specific secure network types. What you see here depends entirely on the hardware, so check your network's requirements before making any changes. The Details tab is extremely useful when dealing with unknown or problematic devices. Its drop-down menu provides a wealth of information about the device. Most importantly, selecting hardware IDs displays the vendor and device codes, VN_ followed by 4 characters and DV_ followed by 4 characters. For example, VN_14E4 and DV_4380 identifies a Broadcom 802.11 AC network adapter. Searching for these codes online will almost always find the correct driver. The Events tab logs all errors and warnings associated with the driver, including the time and date of each event. The View All Events button opens the full event viewer, which provides error codes in the format 0x000 and more. You can also attach tasks to specific error events, for example, displaying a message prompting a user to call support when a particular error occurs. 2 more important categories deserve attention: software-related problems and physical Wi-Fi interference. On the software side, the most common issue is vendor Wi-Fi management utilities that conflict with the network configuration. These utilities, bundled with driver installers, have been known to be completely unable to connect to certain network types, especially secure enterprise networks. In most cases, uninstalling the utility leaves the driver fully functional. The Windows Wi-Fi connection subsystem in modern versions of Windows is highly robust and doesn't need the vendor utility to work. The more significant software threat to network performance is bandwidth-hungry applications, cloud backup services, file sync tools, and peer-to-peer applications. These can consume so much bandwidth that other users on the network effectively lose connectivity. Well-designed applications like CrashPlan and Dropbox allow you to set bandwidth limits per connection type and restrict usage to specific networks. Check these settings before deploying such apps in a business environment. Wi-Fi interference from the physical environment is a separate but equally important issue. The biggest factor? The building itself. In North America, most residential construction uses wood framing, which offers relatively little Wi-Fi resistance. Elsewhere in the world, particularly in Europe, Asia, and older buildings, walls of thick brick or stone can block Wi-Fi signals remarkably effectively. The best solution for severe physical interference is a mesh network system. Mesh networks use multiple coordinated routers placed throughout a building, connected by Ethernet or wirelessly, to provide even signal coverage. A companion mobile app typically guides optimal router placement. This is superior to simple Wi-Fi repeaters, which extend range but lack the coordination of a dedicated mesh system. Where wireless is not viable at all, wired Ethernet remains the gold standard. For mobile devices without built-in Ethernet ports, a USB to Ethernet dongle solves the problem immediately. Even without involving PCs or software, the hardware infrastructure of the network itself can be a source of problems. Let's start with network switches. Despite having no moving parts, switches can be surprisingly unreliable. The good news is that diagnosing a faulty switch is usually straightforward. A failure almost never affects just a single PC. More commonly, a bank of ports on the switch or the entire switch will fail at once, taking down multiple devices simultaneously. When you see several users on the same network segment lose connectivity at the same time, look at the switch first. Routers require more investment and consideration. Quality matters significantly. Avoid cheap, consumer-grade routers in business settings. Key features to look for include expandable mesh capability for coverage and, most importantly, support for multiple Wi-Fi SIDs. Multiple SIDs allow you to isolate network segments. You can give BYOD and guest devices access to the internet and perhaps a shared printer, while keeping them completely isolated from sensitive internal shares and servers. This is a critical security feature. Firewall and security appliances present their own category of risk, and it typically centers around firmware updates. A firmware update can wipe configured whitelists, the lists of permitted websites that content filtering appliances use. Recovering those lists manually can take hours of tedious work. Before any firmware update on a firewall or security appliance, always export and back up your whitelist and blacklist configurations. Understanding how to control driver updates differs meaningfully between Windows 7, 8.1, and 10, and the differences have significant implications. In Windows 7, you access driver update settings through the control panel, then System, then Advanced System Settings, then the Hardware tab, then Device Installation Settings. Here you have three options. Always install the best driver automatically. Install from Windows Update only if a local driver isn't found, or never install drivers from Windows Update at all. Bear in mind that disabling automatic driver installation also means Windows won't search for drivers when you plug in new hardware. Windows 8.1 follows the same navigation path, but simplifies the options to just two choices: always install drivers or never install drivers. The same caveat about new hardware applies. Windows 10 is a fundamentally different story. Microsoft changed the policy with this release. Security, stability, and driver updates are mandatory for all users and cannot be blocked through the standard control panel. Navigating to device installation settings in Windows 10 only gives you the option to block manufacturer apps and custom icons, not driver updates themselves. Windows 10 Pro and Enterprise users do have two additional tools. Current Branch for Business defers feature updates for up to 3 months. Long-Term Servicing Branch, available on Enterprise editions, defers feature updates for up to 10 years. Neither option, however, affects security, stability, or driver patches. Those remain mandatory. For all versions that support group policy, Windows Pro and Enterprise, the setting Turn Off Windows Update Device Driver Search Prompt under Administrative Templates System driver installation prevents users from being prompted to initiate driver downloads. This is a useful middle ground that reduces risky user-initiated driver installs while preserving automatic security patching. Let's bring everything in this session together. The starting point is that no computer is truly isolated. Every device, from a desktop PC to a smart refrigerator, is connected through layers of infrastructure to the global internet and, through it, to every other connected device on Earth. This interconnectedness is both the power and the vulnerability of modern computing. The biggest threat to your networks isn't a sophisticated attacker. It's the people using them every day. Unauthorized changes, accidental network switches, and BYOD complications cause the majority of networking support calls. When approaching any network problem, think holistically before touching anything. Ask 3 questions. Is this problem isolated to one device, or are others affected? Has anything changed recently? Has this happened before? These 3 tenets will narrow the cause faster than any diagnostic tool. Wi-Fi driver problems are the single most common issue in modern networking. They're most often caused by driver updates, automatic or manual. Always carry a USB to Ethernet dongle. It is the most valuable item in any network troubleshooter's kit. Device Manager is your most important diagnostic tool for driver problems. The General, Advanced, Details, and Events tabs collectively provide everything from device status and VN/DV hardware codes to full error event logs. Use them systematically before guessing. Finally, manage updates carefully. In enterprise environments, use WSUS to test before deploying. In smaller environments, use group policy to prevent users from initiating driver downloads. And remember, on Windows 10, security patches are mandatory regardless of any setting you configure.